Parallel lines and triangle angle sum. This lesson, lesson 2.3, is a very important lesson. So make sure you go through every slide. Make sure you understand every rule, theorem, postulate, because this will come back all year long. All this information. All right, I love how this lesson starts out. It talks about two parallel lines never intersecting. You should know that two parallel lines don't intersect. But can two lines that intersect ever be parallel to the same line? And it asks you to manipulate. It gives you just specific instructions in part A to figure out if this is possible, not possible, and go ahead and manipulate these things. I don't want to give you the hint, so I want to see if you can figure it out. Triangle measures, or angles in a triangle, have a certain measure. A lot of you already know that, so I'm going to have the solution up here. This is an amazing visual. Basically, what it is it took 1, 2, and 3, those three angles, and lined them all up. So if I cut this triangle up and ripped off angle 1 and ripped off angle 2 and ripped off angle 3 and lined them all up, they would make this straight line. Okay, that's not true for just this triangle. It's true for every triangle. So no matter what I do to manipulate this triangle, look how huge angle 3 is, but angle 1 and 2 with 3 still make a straight line. So hopefully you know that angles on a line make 180 degrees. Well, all triangles do as well. This is a theorem. It doesn't necessarily have a name. I wouldn't recommend memorizing it, theorem 2-10, because every textbook is a little bit different. It's not always going to be the same. But through a point, not on a line. So you have a line and you have a point somewhere not on that line, like anywhere. Then there will be only one line that can go through this point that would be parallel to this line. So if I had a point here and had a line through it, to make it parallel, if even it moved just a tiny bit in a different direction, it wouldn't be parallel anymore. So there's only one line that can go through a point. So point P is off the line, and then there's only one line. And look at these little red arrowheads. Those show that the two lines are parallel. Next theorem. This is the triangle sum theorem. A lot of people refer to it as the triangle sum theorem. This textbook says triangle angle sum because it's using the interior angles. So talk to your teacher, make sure you know which one they prefer, or maybe it doesn't matter. So what the theorem says that if you have a triangle, the three interior angles added together add up to 180. Now on my screen, it kind of looks like it's subtraction. It is indeed a plus sign right there. They are adding. So these three measurements of the angles equal 180. And again, you can manipulate these and grab a calculator, double check. Do all three of those actually add up to 180 every single time? Yes, they do. This is a proof. Now, proofs, again, we've worked on before, but oftentimes we do two-column proofs. But this is not in a two-column proof. It's just step by step for you, but the content and the information is still good. It says given, there is a triangle. Yes, there is a triangle. And sometimes you're given a visual and that's all you write is triangle. I'm given triangle ABC. I need to prove the measurement of angles 1, 2, and 3 add up to 180. Now, I just told you by the triangle sum theorem, they add up to 180. But you have to prove that theorem, so you cannot use that theorem. If you're proving a theorem, you can't use it. So I'm going to click this solution and we can walk through it. And it's nice because this interactive text actually color codes things for you. So it tells you what to do, and it says basically to draw a line parallel to AB. See how there's this arrowhead right here? You're going to draw a line parallel to that through point C. And I'm going to click this and see how it created that. It's like the visual that shows up for you. So it created a line parallel. It does have that same arrowhead, and it created two more angles, angle 4 and 5. So first step, you draw in this parallel line, and then you make sure that you state that these lines are parallel. Now, if lines are parallel, there are 4 rules you should automatically think of. Because if lines are parallel, then alternate interior angles are congruent. Corresponding angles are congruent. Alternate exterior angles are congruent. And same side interior are supplementary. So anytime, every time you are told lines are parallel. You have to think about those 4 rules. Otherwise, there's no point in using parallel lines, because if you're saying they're parallel, definitely at least one of these rules will be used. So step 2, by applying angle addition postulate. So I want you to look at the angles 4, 3, and 5. And again, that's an addition sign. 4, 3, and 5 right here. I am hoping you remember what those add up to be. They create a straight line. So by the angle addition postulate, they add up together to make the total measurement, which is 180. Or you could say because they're angles on the line. Or you could say that these angles are supplementary and create a straight line. So talk to your teacher, make sure you say the rule the way they want it. Visuals, they are just pointing out those 3 angles. Step 3, so we've got these angles. Look at this picture to see, well, okay, I know they're parallel lines. So what? Do I see any same side interior? 5 and this one out here would be, so no, 4 and, no same side interior. Do I see any exterior angles at all? Outside the parallel lines out here? Nope, no exterior. So your choices are corresponding and alternate interior. So corresponding, if this is angle 5, then down here below B, point B, and this line would have to be extended, those would be corresponding, so they don't really help. But alternate interior, 1 and 4 are definitely alternate interior. They're on opposite side of the transversals inside the parallel lines. And then 5 and 2. So if the lines are parallel, alternate interior angles will be congruent. That means they have the same measure. So if we look here at step 3, and I'll even do this, it kind of color codes them. So if you look, 4 and 1 have the same color, and angle 2 and 5 have the same color. So those we know are congruent angles, which means they have the same measure, which is going to really help us out. So I have the conclusion here, but I'm going to show you on the visual. We know that 4, 3, and 5, those angle measures add up to 180. But 4 is the same as 1. So if I replaced 1, and instead of saying 4 plus 3 plus 5, I said 1 plus 3 plus 2, because 2 and 5 are the same. When I replace something of equal value, there's a name for that. That's called substitution. So you can substitute 1 for 4 and 2 for 5, and you would have angle 1 plus 3 plus 2 equals 180. So if you look here, here's all the math and all the steps. I just explained it. If we go back to what we're trying to prove, we are trying to prove that angle 1, 2, and 3 equal 180. But we didn't use the triangle sum. We used parallel lines on there, not the rule parallel lines, because that's not a rule, but we used the concept of parallel lines to use the rule about alternate interior angles. We used angles on a line that add up to 180 or that are supplementary, and we used substitution. Okay, we have the knowledge, we know that they have to equal 180, so what? Well, now you have to apply it. So if you see this triangle TRS, triangle TRS has 2 of the 3 angles. Mathematically, you know they have to add up to 180. So set them equal to 180. Say 32 plus 78 plus x equals 180. That would be taking the information you know from the theorem and writing an equation. Now, some people will just say, oh, take 180 and subtract those 2. Mathematically, it's the same thing, but the problems will get more difficult. So I recommend using the theorem. The theorem says all the angles in a triangle add up to 180. So write the formula. All the angles add up to 180. 32 plus 78 plus x equals 180, and then solve from there. Okay. Once you have that measurement, x, you'll have x, 57, and you could figure out this total angle, QTS. So x, you'll know that by then, plus 57 plus, well, we can just call this t, equals 180. Once you solve for this larger angle t, this total angle, you could subtract the 32 and find this if you need it. Okay, but it doesn't ask for that. It asks for y. Now, there is a way to find y without using triangle sum theorem twice. You'd have to use it the first time for triangle TRS, but look at these 2 angles, y and 78. Those two together are a linear pair. They are angles on a line. So together, they equal 180. So, and the solutions are here. They go through all of it, and they basically show you exactly what I just told you. It's just written out nicely for you, which is, I think, wonderful. Okay, there's another try it. Try to do this one entirely on your own without any help. And this one does have you try to figure out that angle up there on the top. Okay, this one's a little bit scarier, but I'm hoping you remember triangle sum, 59, 57, and x equal 180. Okay, but this only has two measurements, one of which is a variable. You have to know a little bit more. And I'm hoping you remember what these two angles are called and their relationship. My hint would be they're across the vertex from each other. So they are, it starts with a V, vertical angles, which they are going to be congruent. So hopefully you remember that. If not, you need to go back and study that vocab. Vertical angles will always be congruent. Once you find X, you will also know this, and then you can find the rest. The triangle exterior angle theorem is a great theorem, and for a lot of kids it's hard to see, so I'm going to explain it to you. And I tried to move this and manipulate it so the numbers are pretty easy to work with, so I'm going to leave that as an angle of 120. So the triangle exterior angle theorem, or just exterior angle theorem, what it says is that the two interior angles far away from this exterior angle will add up to that exterior angle. So if you look, the exterior angle, angle 1, equals the sum of angles 2 and 3. So I want to explain it. This is how it works. If this is 120 and this is a straight line, then this right here would be 60 degrees. Okay, because 120 plus 60 is 180, and angles on a line or linear pairs add up to 180. So this is 60 degrees. Now, if this is 60 degrees, then 61 and 59 and that 60 add up to 180 as well, because triangle sum. So I want to write on this for really quick and see if you can understand this. So I have 59, and I know that my writing is terrible, plus 61, because I'm writing with a mouse, plus, we'll just say angle A, the interior angle, angle A, angle CAB, equals 180. Okay, now that's the interior angles of a triangle. So if I go to this and I'm going to say, okay, I'm going to switch colors, and I'm going to say this 120 plus that angle A have to equal 180. But the reason isn't because it's a triangle, it's because it's a linear pair, or angles on a line right here. So this is 120 plus angle A equals 180. And then I'll go back to that other color, or at least close to that other color. The 59 plus the 61, whoops, that's double arc, so they're not the same. I don't want you to think that they're the same. And then this angle, angle A, these are all different angles, but they still add up to 180. So let's combine these really quick. 59 plus 61, hey, that is 120. And it will be like that every time. So these two interior angles, let me erase all this mess. These two remote interior angles add up to the exterior angle every time. Okay, and that's called the exterior angle theorem, or triangle exterior angle theorem. Let's apply the triangle exterior angle theorem. So I look at this angle 1. I should remember by the exterior angle theorem, these two add up to angle 1. So that's what the theorem says. So write the equation like that. 75 plus 45 equals x, or angle 1. And you can solve it. And the solution is here. And the math, I hope you understand, and you can understand fairly quickly, but the two inside equal the outside. Now, here's applying triangle theorems, but you could use more than one theorem. You might be using the exterior angle theorem. You might be using triangle sum. You might even be using angles on a line or linear pairs. So start with what you can see. Every kid is going to be a little different, and every problem is going to be different. Like I might see something, 55, angle 5, and 45. Right away I see, okay, this is a triangle. It has 180 degrees. So I can calculate what 5 would be, angle 5. But someone else might see, I look at angles 55. I look at angle 5 and this one right by above it, the vertical angle. I might say this is angle 5, So the one right above it is angle 5. So look at what you see and go from there. Sometimes it's easier to start in certain spots, so keep looking until you can find something that you can do. There is one thing you have to know, and this is important. Each of the shelves is parallel. So if it looks like a horizontal line, it actually is a horizontal line. So this 75 right here, that is a corresponding angle to this angle 1 and 55 together. And so if they are told that they're parallel, you're ever told they're parallel, look for corresponding angles, alternate interior, same side interior, and alternate exterior. And yes, you will get sick of me saying that, but that's what you have to think of every time you hear the term parallel. Here's one, same idea, just a little bit different numbers and problem. Okay, bottom line, concept summary. Triangles add up to 180. The interior angles of a triangle will always equal 180. That's what this is, and often it's referred to as the triangle sum or triangle sum theorem. The exterior angle of a triangle, if one side is extended, the two remote or far away angles inside will add up to the exterior. And this is referred to as the exterior angle theorem or exterior angles of a triangle, something like that. So use all these rules we've talked about to finish the lesson and complete the assignments. And some of you will have to do other things in this lesson, and some of you will do different assignments. So talk to your teacher, make sure you know what you're supposed to do.